Okay, so now we're going to do problems 11 through 15. All right, and again, I'm making judgment calls on what I think is quicker to be uploaded into your knowledge banks. Let's find out. All right, problem 11 on your test. Oh no, problem 19 on your test will become problem 11 on the test on Monday. And it is an addendum question, which I will eventually ask as one question, but right now it's two. You found in the previous problem the average rate of a function. If you don't remember how to get that at this point, go back to the first video, problem 1. I'm assuming we know how to get the average rate now of x cubed. 2 gets 8, 3 gets 27. Change in y, 19. Change in x, 1. So there's your average rate. And the next question is, when is the instantaneous rate equal to the average rate? So all you have to do is set the derivative of the function you worked with to the actual rate, average rate, and then solve it. And that's what we call letter C. 19 divided by 3 is close to 6. The square root of 6 is definitely between 2 and 3. Square root of 4 is 2. Square root of 9 is 3. Viable candidate. Now it's really plus minus, but the minus tangent's down here. So one more time, you got this function. It's hard to draw slope of 6 here, so I'm just going to box this in and level it out a little bit, like that. Here's 2,8. Here's 327. And what you found, the average rate was going up at 19 to 1. And there's some place on the curve, we'll call it the letter C because A and B are taken, where C produces a tangent that is parallel to that. And that is called the mean value theorem in derivatives. Okay, and you're trying to find where in the curve you're also going up at 19 to 1. Okay? All right, so let's say we have a new function, x cubed minus x. And I'm going to give you the rate of change because hopefully in the earlier video you now know how to get it. The only way you can make a mistake if you know what you're doing is to make a math error, and we all do. I make my fair share. But if you give it your thoughtfulness and you stop doodling all over papers and actually get a nice piece of paper out, a nice sharp pencil, line up your equal signs, you can eliminate half of your carelessness. The other half, do the problem from another perspective. All right, so you got the average rate. How do you find where on the interval you're going up at 27? Where are you going up? At what instant are you going up at 27 to 1 on this calculation? Again, set it to the derivative of the calculation, which is 3x squared minus 1. Well, it looks like I got to bring the 1 over. 28, I got to divide by 3, and I got to take the square root, and that's your C for this problem. Okay, that's 30 divided by 3 square root of 10. So you're near the number 3. Oh, that's in the interval 2 to 4. Acceptable answer. Okay, so I'll give you the square root of x. You find the average rate, which is 1/3. Oh yeah. Change in y, 3. Change in x, 9. 3 over 9 is the change in y over the change in x. That's the average rate. Average rate. When does it equal the instantaneous rate? Well, I need to know how to find the rate at which something is changing at a given x value. That's called taking a derivative. At this stage of the term, you should have memorized what the derivative of square root of x is. 1 over 2 root x. Oh, I should have done it here. 1 over 2 root x. Let me clean this up so that we can do the work. There we go. There we go. Okay, we got a nice clean spot here. I think what I'll do is set that equal to that because the numerators are equal. So it looks like 3 has to equal 2 root x. I'll keep my equation, those equal signs somewhat lined up, although it looks like I'm drifting off to the right. So 3/2 equals the square root of x. Sure looks like I have to square this. And if I do, then my C is 9 over 4. 9 over 4 is a little bit bigger than 2. Oh, that's between 0 and 9. let's see. So if I go from 0, 0 to 9, 3, looks like my average rate of change is about a 1 to 3 ratio. I wonder where I'm going up at 1 to 3. Looks like right about there. Yeah, looks like that value. Does that look like, if it's between 0 on this side and 9 on this side, does that X value look like 9/4? And I would say yes to that. I would say yes, it does. All right, so that's going to be problem number 11 on Mondays, on Tuesday's test. That's right, I'm moving it to Tuesday. I've learned my lesson. Never give a test on Monday. People work so hard. They're so tired after the weekend from working so hard that I just can't. I have empathy for students who work all weekend long and come in Mondays. All right, so x squared minus 4x plus 7. We're going to learn how to write this as an integral. All right, because it's really a couple of just 2-3 steps. And the first step is to find a point on the curve. I usually use the number 0 or 1 or 2 in class. Let's use 2 just for the heck of it. 2. That becomes 4, that becomes minus 8, and that becomes plus 7. That's 4 minus 1, that's 3. Okay, so you find a point on the curve. The next thing you do is you write an integral sign, you put a 2 here, and way to the right, you put a plus 3, and you put a dx there. That much you can do right now. Oh, I'm sorry. D any letter other than X. You really shouldn't use X. Some of the textbooks years ago, you couldn't, the calculators and computers wouldn't work with it. So any other letter, a dummy variable, I like to use M. It's easy to write. I write a decent M. I'm a lot of trouble with some of the other letters. I'm challenged. All right. Now, the next thing is when we integrate, we're going to get a statement in M. We want it to become X. Well, when you start dropping X into that integration, it comes back to X. And, well, this comes from the area under some curve. I wonder what curve? Oh, yeah, the derivative. But I'm going to write the derivative in terms of M. 2M minus 4. That's that problem. And reason why, if X was 2, 2M minus 4, right there is 2, by the way. You know what? I hate to say it, but no area. I can't, if I'm going from 2 to 2, how do you draw area unless you move to the right or move to the left? I'm not moving. There's no widths to my rectangles. I guess I get 3 out. I guess it works for that. Yeah, let's go, how about from 2, let's go from 2 to 4. 2 to 4, well, that's a triangle, right, with a width of 2. 2 times 4 is 8 minus 4 is a height of 4. It looks like I'm going up from 3. Looks like I'm going up 4 units. That should get 7. So if I put a 4 in here, I should get 7 out. 4 squared, 16 minus 16 plus 7. Yeah, sure did. 2 to 4 gave me that. Yeah, worked. Let's repeat it now with another problem. We're doing 3 in a row. Remember, you're stopping the video. This is problem 20 on your test, 12 on the test on Tuesday. You're stopping the video. Y equals x cubed minus 5x. You're going to write that as an integral expression. Well, I hope you put x cubed minus 5x and you put some number in for x. You know, I suppose I could do, for this one, I'll do something other than 0. Let's do, how about 3? 27 minus 15 gets me 12. Step 1. Spend some time on this. Step 1. Do you remember what step 2 is? Integrate 3 to x, put the 12 out there. 9 plus 12. I got to write something here. and I'm done. Any idea what you write? Something with a expression without x. I like m. 3m squared minus 5 dm. And that measures the curve under 3m squared minus 5. And I'm measuring from 3. 3 gets me somewhere up here on the curve. So if I measure area to the right, I've got some acceleration. If I go to the left of that, it looks like I've got some negative coming down. Then it's going up faster and faster and faster. And then it's slowing down. And then it's area. It's a little, we're gonna study this, but it's probably confusing you right now, so we'll stop. But I would get this graph. If I added all these areas up, I would get these graphs. All right. But I just want the mechanics right now. So let's do another one. How would you do y equals e to the x plus 2x plus 9? How would you do that one? I got to find a point on the curve. E to the x plus 2x plus 9. Remember, you're stopping the video, right? Oh, this is definitely where I pick a 0. Oh, God. Automatic. And I'd be careful, too. 2x disappears. This doesn't disappear. And I make sure I knew what e to the 0 was. 1 plus 9, 10. So you got to be able to have a little understanding of the algebra there. Next step, you're writing this as an integral. Probably should draw an integral. And then use 0 and 10 and put an x there. I'm one step away. I like the letter M. Whoa, the derivative of this. Derivative of this is going to assign the heights of the rectangles. And dm is going to assign the widths of the rectangles. And I'm going to add an infinite number forever. Under what curve? E to the m plus 2. That's it. E to the m plus 2. dm. I said I could draw a good m and look at that terminal m. Right? 3 steps to the problem. 3 steps. Why don't we do one more? Why don't we do, how about cosine x? Cosine x and 4x. And let's write that as an integral expression. Once again, 0 would be a great choice. Because if you put 0 in, it gets rid of that. But the cosine of 0, got to be careful. You got to know your algebra and trig, is 1. We got a point on the curve. How do I write it as an integral expression? I hope you went 0 plus 1 and x. Hope you did that. Oh, I like the letter M. dm. What goes in the parentheses? I hope you said the derivative of this, which in this case is minus sine m. Don't have enough room. Integral 0, 1, x minus sine m plus 4. And feel free to take the minus sign right out of there if you wanted to. Not to confuse you at all, but if you don't like the minus sign, for those of you who are doing really well, you can get rid of it. Just start adding up your area in the other direction. Everything reverses. But we can come back to that. And I wouldn't have expected you to do that yet, but right there, yes, I'm hoping you're there. Let's do one more. Another way to write y equals, why don't we do x to the 5 plus 3x squared minus 7x plus 2. Yes, I think I would start taking 0, 2 immediately, so I wouldn't have to do any work. 0, 2, a polynomial. Why not? Unless I ask you to use a specific x sometime. X, there's step 2, that's step 2, step 1, step 2, step 3, dm. Oh, 5m to the 4th plus 6m minus 7. Okay, hoping you get that right. All right. 13, problem 13 on the test. I'm going to give you a derivative. I'm going to give you an expression. And I'm going to ask for, when is y increasing? And we'll come right back. So it's going to number 25 on your test. That type of problem, I don't know if it's the exact one, but that type of problem will become number 13 on Tuesday. Well, we look at the critical numbers. This is sine slopes. You know, the slope, are my y's increasing at this instant? No, my slopes are going down. Oh, well, that would mean that I'd be less than 0. What makes something increasing? The tangent line has a slope that is positive. That's just step 1. We have some critical numbers here. Many of you are still struggling to graph this. So why don't you do it as a sign chart? Okay, why don't you do it as a sign chart? I'll have to look in the textbook, get a better sense of how the sign charts are written because I haven't used them in so long. Honestly, I forget. I know that -10 over here, let's see, I got 3 critical numbers. So maybe this is the best way to do the sign chart is to label -10, +4, and what have I got? 0. Okay, I mean, you can do it that way. And then ask yourself, if I put a number bigger than 4, is the expression bigger than 0? If it is, maybe I'll write yes. Yes, it is increasing. And I'll write positive or negative. So we pick a number bigger than 4, a million. A million, a positive factor. A million minus 4 cubed, a positive. A million plus 10 squared is a positive. Oh, the derivative, slopes. Slopes, positive. All right, so that's 4. At 0, well, you know what? At 0, there's a sign change. So I got a feeling, oh, at 4, I'm sorry, I'm looking at 4 now. That was to infinity. Oh, there is a sign change at 4. Oh, so this is going to be negative, right? But let's do it out. Let's just prove it's negative. Negative, so that's going to be a negative number. If I put in a minus million, a negative times a negative times a negative, that's a negative number. And what did I do here? I made a mistake, didn't I? Negative. Oh my God. Been at this so long today, I'm starting to make foolish errors. So I want to put in a 3. So I'm sorry, a number between 0 and 4. I just picked a negative. I have to pick a number between 0 and 4. So I'm thinking too much here. So if I pick a number between 0 and 4, like 3, that's positive. So I don't do sign charts. So 3 minus 4 cubed, that's negative. Anything squared is positive. I don't look at that again. I'm just going to write positive every time. Okay? No sign change. Oh yeah, even exponent, no sign change. What's a positive times a negative? A negative, we said that would be true. So that's not going to work, right? Negative slopes, y values are going down in the table. All right, and at -10, oh, at 0, this is a 1. That's a sign change. It's going to be positive again. Let's pick a number between -10 and 0. Let's do -5. Put in -5, that's negative. -5 minus 4 is -9 cubed. Is 3 negatives, I think I just said? Yes, that's negative. That's always positive. Oh, that's a positive product. Yeah, that's true. And then at -10, no sign change. It's going to stay positive. This is where I should have put in -1 million. -1 million is negative. -1 million minus 4 cubed is negative. And that's always positive. So that product is positive. So what do we have? When is y increasing? Y is increasing from -infinity to -10, union -10 to 0. Because remember, if you put -10 in, you get 0. 0 is not greater than 0. So that number doesn't work. That number doesn't work. That number doesn't work. But 4 to infinity does. Okay? Now, I choose to do sign chart graphs because graphs give you a little more information on some other questions where this doesn't. I know how many points of inflection this is going to have if I graph it. I'll try to expound on that in the second half. So I would have done this. I would have picked -10. I would have picked +4. I would have picked 0. And I didn't, I wasn't thinking while I was talking. No sign change. I would have put a dot. 0 sign change. Okay, this is a cubic root, and if I put a number bigger than 4 in, positive, 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 cubic root, 0 is a linear root, and 2 is a quadratic. Okay, so when is it positive? Once again, same answer, right? Same intervals, -infinity to -10, -10 to 0, 4 to infinity. So you decide which one's going to get you a right answer on Tuesday. Maybe after we do 3 in a row now, I'm not going to talk. We're just going to get the answers. Maybe this will spring in to focus for you. I now know that this function here has 1, 2, 3 points of inflection. Points of inflection occur when a graph is going up fastest or down fastest over an interval. That implies that if I just mentioned the rate of change of this function being a max or a min, right? Max or a min, which is the first derivative, right? So the max and mins of the first derivative translate into points of inflection. As long as it changes signs, got to be careful. It gets tricky if this came back down and then back up. If it didn't change signs, then no. Oh, that is a min. Excuse me. That is a min here. So I just confused my thought process with something. That would be a point of inflection. My fault. I was thinking of something else. So the max and mins of dy dx are going to get you points of inflection of the original function. All right. I was thinking about the second derivative for a moment. Let's go back to this one. First derivative is equal to, how about we do minus 2x squared, x plus 4, x minus 3 cubed. Okay, and let's find out when this is decreasing. Decreasing. So you've got to decide which one you're going to do. Pause the video, pick your decision, make your decision, and go do the problem. All right, you're done. Good. Finish that quick. All right, I like to do the graph. So let me just think here for a minute so I don't make a careless error. And 3 cubic root. If I put in a big number, that's always negative, right? Right? Because you square and then multiply. Don't square that and say 4x squared, for God. Okay, -4 is to the first power. So that's going to have a sign change. So it's going to have a sign change. So I got a negative. That's why I was doing that. If I put a big number in here, like 1,000,000, that's a positive. Big number cubed is a positive. So I now know that this is going down. Okay, so cubic root, quadratic root, linear root, that's what the graph looks like. Sign chart. We got 0, -4, 0, and 3. Those are the critical numbers. If I put a number bigger than 3 in, I get a negative. If I put a number between 0 and 3, I get a positive. Take your time with it. If you put a number between -4 and 0, you get a positive. And if you put a number less than -4 in, you get a negative. When am I decreasing? When they're negative, right? Hopefully you can see it here. So these x values work. -infinity, 2, -4, 3, to infinity. Okay, so -infinity to -4 union, 3 to infinity. Let's do another one. All right, so if I said y prime is equal to x squared minus 4 times 5x minus x squared, x cubed. Let's make it x cubed. Well, obviously, you're going to find the critical numbers. You got to factor it. And that's a prerequisite for taking calculus, that you know how. So x plus 2, x minus 2, factor out an x, and you get 5 minus x squared. Well, I'm not going to ask this level of difficulty on Tuesday. And the reason I'm doing this level of difficulty right now is because we're going to basically double up on this question over at the next one. You should rewrite this. Oh, I guess I got to talk about something. How do you factor 9 minus 4? Well, the Greeks saw it as a difference of two squares. 3 plus 2, 3 minus 2. What is 3? It's the square root. What is 4? It's the square root. They work with the square roots. So, good news for you. You can factor any difference. I can factor j minus star. I can factor that. Square root of j plus square root of star times square root of j minus square root of star. In other words, 7 minus 3 as a product. Square root of 7 plus square root of 3, square root of 7 minus square root of 3. Nobody does this. Nobody does that, but you could do it. There's nothing preventing you from doing it. So you might want to look at this subtraction. Man, I got two numbers. You might want to, think of it as square root of 5 plus the square root of x times the square root of 5 minus the square root of x. All right, so I'll write that there. Square root of 5 plus the square root of x times the, square root of x squared is just x, excuse me, times the square root of 5 minus x. I'm not sure I said that correctly a moment ago. Okay, it's been a long day. All right, so I got all kinds of critical numbers here. And I guess I'll do y is decreasing again. So first power, first power, first power, first power, first power. Everything changes signs. I got to change at -2. We'll call that -2. I got to change at +2. I got to change at 0. I got to change at 0. I got to change at +√5, which is bigger. Don't worry about the scale. That doesn't matter. And I got one at -√5. If I put a huge number in, positive, 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 ooh, negative over here. The bigger the number, like a million, that's a negative. This is actually going down. Boopity, 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 boopity. What am I decreasing? Square root of -√5 to -2, 0 to 2, square root of 5 to infinity. Again, that's what the graph would look like. And every interval that is a negative y value, that x produces a negative y. These x's produce negative y's. These x's to infinity produce negative y's, negative y values. Okay? So that's how you would answer that. It's exactly the same question when we're talking about concavity. Exactly the same question. Right? Except we're saying the second derivative. Second derivative can be written, a couple of different notations. These are the most common. Right? Nothing to do with squaring here. Nothing to do with squaring. I've just taken dy dx, and I'm taking the change in that with respect to x. And you can see why someone might write it that way. Okay. All right, so let's say concave down. When is the original parent function, and there's y prime in between, right? But we're talking about up here. When is it concave down? Well, got to do the same stuff. So you can do a sign chart. I'm just going to keep graphing because I think it gives you more information. So what the heck am I? I'm at 0. It's to the 1. Sign change. -5. Sign change. -7. Oh, -7. Again, sign. It's changing everywhere. So if I put a big number in, well, I know that's going to be negative. That's going to be positive. That's going to be positive. My product is negative. Bumpity, bumpity, bumpity. I now have the graph. Where am I concave down? When inputs, which are the x letter, right, get me outputs, which are all these y values, where am I negative? Here. What's that interval? -7 to -5. Here. This interval gets me negatives. from 0 to infinity. All right, let's try another one. And you pause the video. Remember, you're pausing the video. This is problem number 14 on your test. I guess it's if that last one was problem 25, and this is probably 26 on your test, probably number 26, types of problem I asked. So let's look at x to the fourth times x minus 2 cubed. All right. Oh, there are only two critical numbers here, 0, putting a dot because it's even, 2, putting a dash, no sign change here, sign change there. All right. So it doesn't matter. It doesn't matter if I pick a number bigger than 0, 10, or less than 0, -3. If I do it to the fourth power, I'm not getting anything other than a positive and a positive. Okay, so if I put something bigger than 2 in, I hope we can see that you can sense the bigger the number I put in for x, the bigger the product. Sign change, no sign change. Let's do increasing. Concave up, excuse me, second derivative. When am I concave up? When I'm bigger than 0. There's only one place that happens. X is bigger than 2. Okay, let me get this, my God. Yeah. When I get tired, boy, I start making stupid mistakes. Okay, let's do another couple. All right, second derivative. Let's look at minus 3x to the fourth times x squared plus 9. Can't factor that. Can't make it 0. So I wouldn't do that to you. I'd do x squared minus 9. All right, and your challenge is to rewrite it as 3x to the fourth times x plus 3, x minus 3, and then graph it. Sign change at 3, sign change at -3, no sign change at 0. Put a number in, huge, positive, huge, positive, huge, positive times a negative is a negative. What do you get when you multiply a negative times a positive times a positive? You get a negative. I'm going down when I pick up big numbers here. Sign change. No sign change, sign change. Original question, concave up. Concave up is when you have positive y values. Positive y values means you have positive acceleration. Vroom! Grandma's accelerating on 91. When is she doing it? -3 to 0, 0 to 3. Okay? The ability to answer this is not calculus. The ability to answer it is how much practice did you get on that in your last class. And if you didn't get enough, hopefully over time you can close that gap in this class. All right, one more problem, and then I'll upload these videos. And I'm coming in tomorrow early to keep this process going. I've had a hard time with the technology today. Canvas changed the way they do things. They shouldn't do that to an old man. Oh, what am I going to do with this? Well, how do I write that as an integral? Oh, I forgot. No, I didn't. I remember. 0 gets me 7. And I want 3m squared. Oh, I want an x there. 3m squared minus 3 dm. Oh, yeah. I remember how to do that from all the practice over there. Good thing I did that. Well, if I know how to go from here to here, I should be able to go back again. I should be able to do the integration and go back to this. And that's the next question. And that's going to be question 15 on your test. And it's 25 is the one that you had last time. Okay, so I'm going to give you statements like this, and your goal is to get back here. All right, so let's do a couple. Let's do a couple. Let's go from 2 to x, 4m minus 2 dm plus 9. Okay, so looks like I got to integrate this. Looks like I got to integrate. That's my first step. Do I know what 4m came from? Oh, yeah, that's from 2m squared. Do I know what minus 2 came from? Oh, yeah, that's minus 2m. Do I know what to do with the 2 and an? Oh, yeah, supposed to drop it in. And then the last thing I'm supposed to do is add 9. I know that's supposed to be one of these things because the guy here with the marker's been telling me to do that for the last month. Oh, If I drop x into this, I think I get 2x squared. If I drop x into that, I think I get minus 2x. If I drop 2 into this, I think I get 8. I got a minus sign. If I drop 2 into that, I think that's 4. I think I can doctor this up. I think what I was looking for, can you see it? Yes, is 2x squared minus 2x. 8 minus 4 is 4. Minus 4 plus 9 is plus 5. Let's do another one. You pause the video so you can get your practice. In the second half of the term, we'll really I'll try my hardest to get you to see what's going on mathematically. Okay, but right now, let's say I give you y is equal to, how about we go from 3 to x 4m squared. Let's make it 6m squared. I'm not trying to get you to work here. I'm trying to get you to mechanically see what you're supposed to do. Plus 5m. Do I like that number? No. Plus 6m. Let's go with the 6's. dm plus 2. Okay, remember you're pausing the video. You're going after it. Let's see, I'm supposed to do something, this integral sign. Oh yeah, 6m squared came from 6m to the 2 plus 1 over 2 plus 1. 6m to the 1. 6m to the 1 gave me plus 1 over 1 plus 1. And I'm going to go from 3 to x. Now, the beauty of a marker and an eraser is I can take this and say, oh, that's 3. I can do 2 plus 1 and say that's 3. And I can divide 3 into 6, and I can call that 2m cubed. And I know many of you could have gone from there to there immediately, which is great. 6m squared over 2 becomes 3m squared. And I forgot to write the plus 2 over here. That's the last thing I'm going to do. Because if I go from 3 to 3, this becomes a big fat 0. Can't accumulate area if you have no widths. So I know this is a parentheses minus a parentheses plus 2. What am I going to drop into the first parentheses? Oh yeah, x. That becomes a function in terms of x. That's what I was looking for. Oh, 3 cubed, 27 times 2 is 54. Addition, addition. 9 times 3 is 27. That looks like 2x cubed plus 3x squared. 81, I think. 81 and 81. That's minus 81. Almost made a careless error here. Plus 2. Looks like minus 79 gets the job done. That function could have been expressed this way. 6m squared plus 6m looks something like this. And you're measuring from 3. You're measuring the area this way, and then that way as well. This will be negative. Going backwards, it's actually positive. And going this way, that's going to be negative forever. So you're going to get yourself a cubic. Oh yeah, it was a cubic. Yeah. All right. I don't remember how many of those we did. Well, I hope it's enough. I hope it's enough. That's problem 15 on your test coming your way. Well, looks like I'm going to stop the video.